So now that I've given an overview of what a functional interface is, let's take a look at perhaps the simplest functional interface, the Java predicate functional interface. And we'll see how it can be used in conjunction with lambda expressions and method references in order to do various types of tests. And we'll show how to apply it to a concrete, concise example, which is available in the EX8 project in my FP folder and my modern Java GitHub repository. This particular example showcases the use of the HashMap class and the set interface in the context of the Java collections framework. Hopefully you're familiar with Java collections. If you've worked with Java any length of time, you've undoubtedly used Java collections. And we'll also talk about how to compose Java predicate objects together. So what is a predicate? A predicate is a functional interface that performs a test that either returns true or false. And you can see here that it's parameterized. It's a generic interface. It's parameterized by a single reference type. And that's the type that's passed to a method known as test. So there's a single method called test that takes something of type T. This is what's known as the signature of the abstract method. It's called the function descriptor. And it basically describes the signature of the lambda expression or the method reference that can be legitimately passed as a parameter to a method that takes a predicate. And if you don't get a match, if the descriptors of the functions don't match, then you'll get a compiler type error, which is exactly what you want because you want to have strong typing in these cases. Let's talk about how to apply the predicate functional interface. This is a fun little example that's available in this project at the link at the bottom of the slide. And it shows how to use a predicate lambda expression in the context of the Java HashMap remove if method. So let's take a look at the example. The example is somewhat whimsical. It's going to create a hash map that will map the names of the Three Stooges to their purported IQs. This is all in firmly in fun and jest. The Three Stooges were an American vaudeville act back in the, I think the 30s and 40s in the US. And they weren't really stupid at all. They're actually very smart. They made a lot of money pretending to be complete numbskulls. So I gave them very low IQs just as a lark. But I'm not really making fun of them because they were making fun of themselves. So we make ourselves a stooge map. And you can see Larry has 100, Curly has 90, Mo has 110. Mo was always the brains of the Three Stooges. So we make ourselves a stooge map. And then what we're going to do is we're going to use a predicate lambda that's we show down here to remove all the entries in the map where the IQs, where the values are less than or equal to 100. So we're going to call the remove if method on the set of elements in the map, and we're going to remove anything that's less than or equal to 100. And what will happen is that this lambda expression is actually used to implement the test method of the predicate inline. So it's basically an inline method call. In this particular case, the entry, which is the entry arrow part of this lambda expression, is short for entry string, comma, integer entry. So it's basically the map entry. We're using type inference to avoid having to type all that extra stuff. So let's talk about how the Java collection interface uses the predicate functional interface. And here's the implementation of the remove if method, which is part of the Java collection interface. And you can see that with modern Java, namely Java 8 and later, there's actually a new type of method qualifier called default. And if you add default to an interface, that provides a default implementation of that method. So interfaces are no longer just about method signatures. You can also have method implementations or default method implementations. So in this particular case, we're going to have this remove if method defined by default in collection. Now, some implementation of collection can modify it if they want, but this is what you get by default. So what happens here is we're passing in a predicate, and it has this really funky generic syntax, question mark super E. And super is what's known as a lower bounded wildcard that restricts the unknown type, type E, or sorry, type question mark, to be a specific type or a super type of that type. So it could be something that was a super type of type E. And so in this particular case, we're going to have the predicate parameter bound to the lambda expression that's passed to it. So we're passing in entry.getValue less than or equal to 100. That's bound to the filter predicate. And then down here, you can see that the implementation of remove if will iterate through all the elements in the collection, and it'll call the test method on each of the elements. And if there's a match, if it returns true, it'll remove it from the collection. So what's happening here is this filter.test is actually being expanded into if each.next.getValue less than or equal to 100, then it'll go ahead and remove it. So that's basically what's happening. We're binding the Lambda expression in place of the test call. One other thing you can do with predicates that's kind of cool is you can compose them together using and or methods. So let's take a look at an example that illustrates this. So here we're going to create ourselves two predicate objects, and we're going to then and them together. So the first predicate object is going to check to see if the value of the entry is less than or equal to 100, just like we did before. And the second predicate is going to go ahead and check to see if the name of the stooge is curly. And so what we're going to do is we're going to remove only if the IQ is less than or equal to 100 and the name is equal to curly. So we're composing those two predicates together in order to do a more sophisticated style of removing. So that's what remove if can do by composing the predicates. So that's the end of the walkthrough of our Java predicate functional interface discussion.